Hey YouTube, it's your girl Dr. J back for another quick video. And I wanted to tell you guys what we're going to be moving on to once we finish the Engineering is Elementary series. You guys know I love this series. We have all 20 books from Engineering is Elementary. This one is Xavier Builds a Bridge. And we are going to be finishing up this series this year. There's 20 books, and we do a book probably about every other week or so. We don't finish a book every week, but we'll definitely be finished with the entire series this school year. So I wanted to let you guys know what we were going to be moving on to once we were finished with the Engineering is Elementary series. The Engineering is Elementary series I am a huge fan of. It has just been the most amazing project and program for us. And so I wanted to show you guys what's going to be our next step and what we'll do after that. And we are going to be using these books, which are called Investigate Feats of Engineering. This one is on Canals and Dams, and these books are recommended for ages 9 through 12. This one is Canals and Dams, and it says Investigate Feats of Engineering with 25 projects. It's part of the Do It Yourself series or Build It Yourself series. And I like these books because they have very good information. Like you guys can see in this box, it says, words to know. And it has things like solution, engineering, ingenuity, innovation. So that's kind of the beginning of the book. But you get more words like hydraulic press, physical science, fluid, dynamic load, pressure, water pressure. And so it's going to give them a great opportunity to learn the correct terminology, great for interactive notebooking. I like that it has cute things like notable quotes. And for instance, this one says, Imagination Decides Everything by Blaise Pascal, physicist and inventor of the syringe, hydraulic press, and more. And so it has a little bit of engineering history built in there. They have the Build It Yourself, where it tells, like, this one is going to be a watershed in a tub, and it tells you what supplies you need. Talks about how early civilizations use them, and it gives you information on what you're going to do to build it. And then after you experiment, it says, once you get to the end, it says things like bring on the rain, spritz the watershed with the spray bottle. What happens to the rainfall? Is the runoff clear? Then 8, experiment with pollution. Sprinkle cocoa into one tributary. Spritz the watershed. What do you predict will happen? What does runoff look like now? What conclusions can you draw about pollution's impact on watersheds? And then it talks about try this. Populate the watershed. Add toy houses, farms, and trees along the river. Use chunks of wood to represent buildings and businesses. And so it gives them opportunities to expand and just gives, really good information on each thing. Like this one, when it goes into canals, it gives some geography information and that sort of stuff, when they're used, how they're used. And so this one, again, is Canals and Dams. And this one is still the same series, Investigate Feats of Engineering. This one is on skyscrapers. And so again, recommended for the 9 to 12 age range. And it says, skyscrapers, investigate feats of engineering with 25 projects, invites children ages 9 and up to explore the innovation and physical science behind these towering structures. Trivia and fun facts illustrate engineering and ingenuity and achievements from the ancient pyramids to the Empire State Building. And so, again, it has words to know section. This one has skyline, structures, skyscraper, landmarks, cityscape, engineer, innovate, and technology. And then the words get more advanced as they go. Words to know, prototype, civil engineering, public work, tension, compression, buckling, shear, live load, facade, trimmer. It has a try this section. It says test compression and tension forces. Use a marshmallow, liquid stick, and piece of dry spaghetti. Place force on the marshmallow, compressing it by pressing on the top. Notice how it squishes and shortens. Does it hold up under pressure? Now apply tension by pulling on the sides. What happens? Vertically stand the liquid. Compress it lightly by pushing down on the top with one finger. Does the liquid hold up against the force? So it has really good questions for them. So even though the projects are more simple, it delves a little bit more deeply into what specifically is happening. It has different projects to build, like building an anemometer. So talks about you need an egg carton, scissors, markers, 2 long straws, clear tape, push pin, sharp pencil with an eraser, and a stopwatch. And it tells shows how you're going to build it, and then it gives information on how to test it. And so once you get to step 6, says the egg cup with the design is your starting point. Using a stopwatch, count how many times it goes by in 1 minute. This number tells you the speed of the wind. For example, 2 revolutions per minute could mean that the wind is 2 miles per hour or 3 kilometers. Try your anemometer in different locations on the same day to see what might affect the speed. And then it has the different rubrics or the different graphs in there, the data charts to put in there as well. So this one is on testing your own center of gravity, and what does that mean? So this one is on skyscrapers. And then this one is on bridges and tunnels. Again, same investigating feats of engineering series. Same age recommendation. And for this one, the projects are engineering and thinking big, building big, the physics of bridges, amazing bridges, disaster, when bridges collapse, building big, the physics of tunnels, amazing tunnels, and tunnel disasters. And then it also has glossary, resources, and indexed. And so the glossary just goes over all those highlighted words that were in there. So they will, learn things like gravitational pull, keystone, lava tubes, legacy, man-made, methane, shear, sewage technology. It has them doing things, even, building avalanches, gives them facts about different things that have happened over time. Again, also, doing a little bit of geography work in there. And while the projects might seem a little bit simple, like if you go through the book and you'll see the projects, they seem a little bit simple, but you can be reminded that these are elementary level books, upper elementary level books, where the kids are supposed to be reading through the book themselves and doing the project themselves and responding themselves. So this again is independent study, and so it's our next step after we finish the Engineering is Elementary series. There's another thing that they're going to be doing as well, and I'll just have to print it out, but they're free PDF files for, it's called After School Engineering, which is a follow-up to the Engineering is Elementary series 2. They have some designed for kids in the 3rd through 5th grade and some designed for kids in the 6th through 8th grade. And so we'll be doing those as well, but those are more group project based, where these are more independent. So these are what the kids will be working on these projects and keeping their notebooks so that, again, they understand the terminology that go with the various examples of more. This is more kind of structural engineering and civic engineering sort of things. So we'll be doing these sort of things, these books as independent study, probably more so with the twins, because Speedster is going to be going in a little bit of a different direction with more kind of robotics and rovers type things. But this is really good, especially for my builder, Salamander. So he'll be doing some of these projects along with some other cool stuff. He's still working his way through the big book of building, which is still amazing. But he'll probably be doing that one for a couple of years, because the projects get extremely intense with that. Very big builds, very long-term builds. So he's constantly going to be working through that. So he will probably be working through that till he hits middle school. But for our next step after Engineering is Elementary, this is where we're going. Hope this helps. This is Dr. J, and I'm out. Bye-bye.